The In Vitro Digestion of Animal-Based Meat versus Plant-Based Meat Alternatives by Maxanne Millerhaller. In a world of increased environmental and health consciousness, plant-based alternatives to animal meat are a promising new market. Plant-based meat alternatives are products that mimic meat in taste and texture, but are made entirely out of vegan ingredients, such as soy or pea protein. There is a growing market for plant-based and lab-created meat that analysts project could be worth $85 million by 2030. These alternatives are particularly attractive to consumers because of their environmental impact when compared to meat. A 2018 report on Beyond Meat conducted by the Center for Sustainable Systems at the University of Michigan found that a 4-ounce Beyond Burger generated 90% less greenhouse gas emissions, required 46% less energy, and had far less impact on water and land use than a 4-ounce beef burger. But where the environmental impact of these products is clearly favorable, there are still many questions surrounding their health impact. The calories, protein content, and saturated fat levels are comparable to those of animal-based beef. However, the sodium and carbohydrate content is higher in the plant-based meat alternatives. Beyond the label, little has been published about the way these products digest and interact with the human body. Previous studies have shown the absorption rate of dietary amino acids in the gut varies according to the type of ingested dietary protein, and as a result, postprandial protein synthesis, breakdown, and deposition are all affected. We know protein digestion is essential for nutritional intake, and different types of protein break down differently, but we don't yet know anything on the digestibility of plant-based meat alternatives. So, my research focused on answering the question, what is the degree of digestibility of animal-based meat versus plant-based meat alternatives? The null hypothesis was that the plant-based meat alternatives and the animal-based meat would have the same degree of digestibility, and the alternate hypothesis was that the plant-based meat alternatives would have a lower degree of digestibility than the animal-based meat. A lower digestibility was expected for the vegetarian products because vegetarian protein sources generally have a lower digestibility due to their containing naturally occurring anti-nutritional factors. To measure the protein digestibility of animal-based meat versus plant-based meat alternatives, protein digestibility was collected for ground beef, the Beyond Burger, and the Impossible Burger using in vitro digestion. In vitro digestion was modeled by homogenizing the samples, adding hydrochloric acid, adding digestive enzymes, pepsin and trypsin, and incubating them at 37 degrees Celsius. The undigested proteins were precipitated out and absorbance was measured. The image to the right shows the samples after trypsin incubation. A standard protein curve was created to determine protein concentration given absorbance. A vernier spectrovis spectrometer was connected to Logger Pro to do this. Digestibility was then calculated using the initial concentration minus the concentration after digestion, divided by the initial concentration, and multiplied by 100, and a 1 ANOVA was run. Figure 1 shows the graph of protein concentration versus absorbance at 594.9 nanometers. It gave an equation of absorbance equals 0.5578 times the concentration plus 0.09911 for calculating concentration. Figure 2 shows the average calculated protein concentration for each type of meat before and after in vitro digestion. P equals 3.6 times 10 to the negative 9th. Using these concentrations, Figure 3 shows the average calculated digestibility for each type of meat using both protein concentration and mass. The degree of digestibility using protein concentration was negative 23.02% for beef, negative 42.92% for Beyond, and 4.25% for Impossible. The null hypothesis was supported because the protein concentration actually decreased for most groups, as the protein was isolated with digestion. The mass was also measured at the end and plugged into the same digestibility equation to get a degree of digestibility of 69.12% for beef, 59.60% for Beyond, and 57.32% for Impossible. However, the sample size for the determination using mass was only 1. Future studies should focus on the mass digestibility in addition to protein concentration of animal meat versus plant-based meat alternatives to account for the protein isolation during digestion.